The Aleph storage system is a dependable, scalable, and flexible software-defined storage system. Among its main features, it can be underlined the usage of a state-of-the-art coding algorithm that reduces the amount of redundant information, but supporting integrity failures as traditional systems do, or even better. A careful decoupling between data and metadata, and middleware that enforces metadata consistency, and its own load balance and allocation procedure, which adapts to the number and capacities of the supporting storage devices. It can be deployed over different hardware platforms, which means that it is fully hardware agnostic. A file to be stored is processed to be recorded in a distributed way among the different nodes that make up the system. Let f be an arbitrary file of size 8 times f bits. Using our coding algorithm, f is transformed into n files called dispersals, each of which has a size 8 times f over m bits, and such that any m of them is sufficient to recover the original file. Also, m is greater than 1 and less than n. Let k equal n minus m be the fault tolerance or the number of missing dispersals that can be tolerated. Then, the same value of k can be achieved with different values of n and m. This means that the integrity enforcement procedure can be parameterized to meet the needs of any application. To achieve fault tolerance, the information about the stored files, which is called metadata, is also replicated. This means that Aleph includes a redundant set of metadata servers called proxies that support business continuity even when some of the components are unavailable. Aleph is designed using a Lego-like approach, which means that depending on the requirements and the budget availability of the organization, it can be started with an initial deployment and evolve over time to include a full set of redundant components, including firewalls, networking devices, monitors, proxies, and a scalable number of storage nodes. Our design supports scaling beyond petabytes. This software-enabled storage system allows continuous uptime through hardware failures, capacity expansions, software and hardware upgrades. This hardware-agnostic architecture prevents vendor lock-in troubles and enables customers to take advantage of future innovations. It can be easily deployed to comply with data regulations in different domains such as medical records, financial transactions, tax records, cataloging, and much more.